Jesus, Luke, just shoot the video. God damn. Okay, so I have been walking by this thing, and it's been sitting. Whoa, whoa, whoa. Behold the power of zoom, boys and girls. I don't even remember what I was looking at in the last video. I left it zoomed all the way in. Apologize for all you out there that now just got motion sickness. I have been walking by this thing all day long. Oh, we're going to go over here and got to do something. I got to go over here and do something. Now I got to go over here and do something. Well, shit. I got to solder something with this over here. Well, okay, now I'm going to work on welding. So I'd slide this thing back and weld for a little while. I've done everything but work on amplifiers today. I swear. And I was just on the phone with my good friend there, Brian Smith, and I was thinking, am I starting to create reasons not to shoot this video? This amp is done. Mr. R, your 2x4 is completed. Now, all we did was simple. We removed the bias, grounded it back to Class C. I removed all the 2-watt resistors out of this thing. Since now I understand how you're going to run this, Mr. R, you basically need this to be a full-up comp box. So we did all the B plus upgrades. One of the things that we did is that they have this tiny little distribution bar that's in here, right down in here. And that little tiny bar, I've seen those fail. And they fail towards this side of the bar because there's an uneven amount of amperage load that takes place. So we center feed these so that the final section gets the most amperage. But then over here on the corner, we've got another little 25 or 30 amp load. So this side of the bar actually gets it's a little uneven. So what I did is I took some really fine ground braid that I have. Where is it? It's up here someplace. Here it is. I got some really fine copper nickel coated ground braid. And I added some girth to this, and I added a bunch of solder to it. That'll help a bunch. It'll help the ground bar from not burning up. I can almost tell you exactly who built this just by looking how it was put together. I'm not going there. The other thing I did, Ron, while I was in here, and I gave you new power wires, gave you a 170 amp Anderson clip. This little 100 amp Anderson clip, this is past its ability to be able to pass amperage. As you see, this will, when I run this, we'll look over here. We'll see that this whole unit pulls about 135 amps. So to be in the safe butter zone, per se, we're going to do the 175 amp Anderson clip. You asked me to send its married partner, which here's a Virgin 175 amp Anderson clip. And those are hydraulically crimped and soldered and heat shrinked and, you know, done professionally. And the next thing I did after I did the power section, and I removed the bias, and I removed all the biasing chokes and all the clamp chokes and the load resistors and the actual diodes that create the load for the circuit, is I noticed that you had these 3 wires inside the box that were not Teflon. So I went ahead and I replaced, gotta love Kobex, everything sticks to it. I went ahead and replaced your remote leads that apparently have burned up in the past. I replaced those with brand new Teflon with a filtering choker on both leads, because we are talking about leads that are going outside the cabinet that aren't coax. So we want to keep RF isolation as best as possible. Brand new resistors on the input-output circuit. And then I turned my attention to the input circuit, the 2-pill section of this box. Let me show you what I mean. We'll see if you guys can see any difference between this and what was in there. So now, if you look at the first picture of our starting point, we had this weird, where'd it go? Oh, I saved it. It's over here. It's over here. It's over here. Yep, saved all of it. Okay, so first off, it's pretty cute to have that little length of shielded coax soldered to the board, tacked going from the variable over to the input network. There was no capacitors between this little circuit here, none, and ground on the input side. So they strictly tuned this box just with resistance. Okay, so they had 2 100 ohm resistors going to the input of the 2-pill section like this. And then they had these two Funkin' Wagnallers going off to ground. Okay. Now, I was on the phone with Brian Smith when I took this apart. There was 9 turns of this wire in the input transformer. Now, I'm not going to lie. The input wasn't that bad. It was under a watt, but it wasn't great. You know what I mean? The other thing is I took what told me it would be tunable. Because there was a time, there was one batch of 2290s that came out about 7-8 years ago that were really messed up. I don't know what Toshiba, the guy on the product line at Toshiba was on that day, but I remember for a quick hot minute, back when Carl owned the business, over at X-Force, they officially changed all their driver sections. Instead of having 2290s, they went to 1446s to address this problem. Fat Boy did something similar. Quite a few guys did this. And they did it for a hot minute, and then they did a recall on the transistors and replaced them. There was a serious problem that took place with them. So I thought maybe, just maybe, because this was built in the Carl and Carol time, back in the day, you know, back when they used to use heatsink that went the whole length of the cabinet. Heatsink literally goes from here to here. I mean, look at the screws. Screw here, screw here. Look at how much wider that is. Nowadays, if you get the heatsink, goes right to the very edge of the pill screw on the 2-pill section and stops right about here. From the same company. And by the way, Omega Force, X Force. Now, it didn't start out that way. It started out, I'm not going to get into that. And now it would be just wide enough for that pill hole and that pill hole to fit it. So they've reduced their heatsink not only 1.5 inches this way and 1/2 inch up here in the front, but they've reduced it 1 inch off each side. Literally the cheapest thing money can buy today, the current product. If you haven't noticed by some of the videos I've been doing lately, it's sad but true. Sad but true. Anywho, we took all those turns out of there, but the first thing that gave me a clue is I looked at the output transformer and I'm like, wow, I don't care how bad the transistors were or how funky the transistors were to tune, it shouldn't have that much wire in the output transformer. So I took a full wrap out of the output transformer, and guess what? The input went down. Because remember, the primary and secondary are hooked together with these little resistors in the middle. The flyback buffer resistors. So technically you can talk from output transformer to input transformer in your tune just by the output resonance of the output transformer. It'll show up as a mismatch tune on the input if the output is too far out of whack, because the RF that can't leave the transformer will thus reflux back through the transformer and pass into the resistors as the only place that it can achieve a reference to ground. I just didn't know that. So anyhow, it shows up as input reflect. So when I pulled that turn out of the output transformer, the input reflect went from like 1.5 watts back to about 1.1 watts. And I went, that tells me everything I need to know. So I went ahead and I took a couple turns out of the input transformer completely. I added 180 puff capacitor to the ground, and instead of adding this uneven induction bump, if you think about going from 100 ohms, which that's what the uninsulated wire is at 100 ohms, down to a balanced 50 ohms over less than 3 or 4 inches, back over to another 100 ohm load. You think about what that does to the signal impedance. It's better just to go ahead from this point on the board, let it fly through at 100 ohms, unbalanced, and then hit the transformer. It's better to have a tuning circuit based around that than it would be the uneven impedance bump without having capacitance in there to tune it, and you're trying to do it with reduction through voltage division and resistance to ground. That's what this is. This is masking a problem. So anywho, with no resistors in line, then the other thing, I took the voltage divider out between the 2-pill and the 4-pill section. So when it came in here, after I did all the B plus upgrades to it, I ran it and I was able to get about 950 peak watts out of it and about 400 bird with the 2950 hitting it. So now let's see what we do with all the full Monty mods on it. Variables all the way open. Here we go. 1,000 watt slug in PEP, 1,000 watt slug in average, 5 watt slug in reverse, back from the bird, 10,000 watt dummy load. We're going to use the 2950 as always, boys and girls, sitting between the Magna Force 2x4 and the 5-watt slug sitting between the radio and the amp. Okay, 2950, driving Magna Force. This has been a busy day, you guys. I'm sorry. I'm actually unwinding as I'm shooting this video. Believe it or not, I actually really enjoy doing the videos. I enjoy getting up here and getting to talk with you guys and just hang out. This is how I spool down, believe it or not. So let's do it to it. 1000-watt slug in PEP. Let me show you input drive first. Hello, mom's vagina. Hello, mom's vagina. Okay, so 20 watts worth of peak power. Here's our pass-through tune. Nice and low. Okay. It's amazing how much better it works when you don't have the extra capacitors in there for the bias keying circuit. There's better ways to do it, boys and girls. Now, I did leave the sideband delay in play. I figured, what the hell? We do have a switch. Might as well leave it there. So we're going to click that in the on position. This is the predecessor to the TNCT, by the way. Just so you guys know. Kick that on. 20 watts worth of drive. Hello, gone. Hello, gone. Hello, gone. Amp meter. Hello. About 130 amps worth of draw. Hello. About 380 bird on the average side of things. Now, honestly, Mr. R, I can't remember if you're a bird average guy or a bird peak watt guy. Because, boys and girls, there's people out there that say, oh, peak wattage is shit. It doesn't mean nothing. Even though the entire ham community is based around peak wattage. When the man shows up, they rate your peak wattage, and transmit stations measured by peak wattage and average power. It's two different forms of measure for two different things. Or if you're an average guy. So, if you're an average guy, you're going to look at that and go, oh man, that's kind of low. Hold up the bandage finger. Just give me 1 minute. Let me hook up the DUR radio. The good old Wolfman radio. Oh, Mr. R, you're going to love this. Okay, so listen to me when I say this. Someday I'll let the coin purse drop and I'll actually mount this thing up here. The reason that I've been holding off on doing that, now I could probably get a little bit more bird out of it if I went to a little bit heavier power gauge wire. I get that. I understand that. I get it. And don't think I don't have the brackets already made up to hang right there below the 955. And I've got yet another bird meter that I guess I would hang out over here someplace. I got the bird meter and the 90-degree ends and all that stuff for this thing to be able to go up there and run. I'm afraid that if I take this radio and I hang it there and then I use it to do input tunes and stuff, that I'm going to end up blowing the final out of this radio. The reason I like using this 2950 is until I got this radio, you guys, and I detuned it the way I did, as I've shown in many, many videos, this radio only does about 25 watts. It's only about half of what it should do. It's a third of what that radio should do. It's got dual MOSFETs in it. I use this radio to do input tunes. I use a dual finaled radio to do it. But I have the radio completely detuned. The reason is the final can take the punishment. Because if I'm sitting over here and let's say I got a capacitor on something and I'm tuning on something, and my reflect meter's over in a corner, let's say with a 95:1 output aspect ratio, I don't want to have a completely hot rod radio driving into a bad input tune because then I'll end up blowing the finals. So anytime that I got to spend pulling this stack of crap apart to pull that radio out, let's say, or pull that radio out, let's say, to replace the finals, I want to try to avoid it. So what I discovered is if I massively detune this radio, okay, set the gate voltage way down low and, make it so it only wants to do about 30 watts. The transistor, I haven't popped a set of transistors in this in like 2 years in the final section. Although I can pop those like cotton candy. Very delicate radio. If you were to see all the stuff that D-Rail puts inside this thing, all the heat sinks and all the other crap I'd have to go in here and move to simply change the final, I'd rather leave it sitting over there on the shelf, bring it over here when I need it, than leave it hooked up and I know myself, I'd probably get lazy and leave it hooked up as I'm screwing with somebody's input tune, and pop, pop goes the weasel. You should see all the stuff he's got in here. The whole back side of this board's got all completely different tuning on it. I mean, the guy went all out on this radio. I mean, I wanted a blackface Cobra 29 Classic, but this is what he sent me, because this is what he had, and I'm really grateful that I got it. Because it allows me to be able to turn it on just like this, and walk over and do shit like this. Watch the average meter now. Hello. Hello, gone. Hello, gone. No joke. Hello, audio. 20 whole watts. Hello, audio. Look at the peak meter. Hello, 10 watts. Now that's not a really justifiable form of measurement. If you think about how a bird meter scale works, over here it's 0, and we got to move all the way over to about here on the meter to get to 50%. And so then you've got 50% of the meter movement, its measuring distance, from here to here. So this is not linear. They say they say that a bird isn't actually accurate until you're in the top third of the freaking meter movement. They, not me. Don't quote me by saying that. I'm saying that's what I've heard. So that's not necessarily relevant. If we wanted to do this, I'd need to put like a 25 watt slug in there but I'm just giving you a general reference that this radio and that radio do the same rough amount of output power. But the difference between the two on the average meter is crazy. So your maximum average watts, of course, is going to be half of whatever your peak power is going to be on AM. Which is 600 bird. 600 bird 2x4 on 14 volts. That's it. That's simple. I'm going to turn off the Whipple blower machine that we've got hooked up on the bottom of that thing. Make sure it stays cool. Mr. R, I'm going to put the lid on this thing, man. I'm sorry. I meant to get with you Wednesday. I did. He's probably thinking I'm full of crack. I called this gentleman on Tuesday and says, man, I'll call you tomorrow. I'll have your amp done. This amp has been literally sitting here since Wednesday. I have been managing my boss's tow business. And because we don't use radios for the trucks there, it's a lot of phone calls. It's a lot of phone calls back and forth. And between that and the actual line ringing for me to take the calls in, plus my own personal business going on over here, you know, this BBI thing, it's been busy. It's been busy. So I'm glad we finally got around to it on Saturday. I had to spend most of the day just doing catch up on stuff left over from this last week. Yay, we're done. I feel like I finally broke the chain there. I haven't done a video since last weekend. Let's see what's coming up next. I got a couple Henrys that are not Henrys, but SV220s I got to work on this weekend. I got this other big colossal construction thing over here I got to finish that I'm going to work on tomorrow night. I swear. It's been one of them days. Just one of them days. I thought I was done shooting the video for this thing, and so I was sitting there playing with my little handheld network analyzer, and I got it on spectrum mode. Check this out. It's our principal carrier. Pretty clean. Not half bad for what this is. I never spent 1 minute in the last little hunk of the video talking about the input tune. I talked all this swag and a schmack about how I rebuilt the input, but I didn't talk about what the actual tune was. Oh, I'm slipping in my old man years here at the ripe old age of 40. Okay, here we go. 5 watt slug in reflect between the 2950 and the Magna Force. If you notice as I'm modulating it and driving it up, the signal is actually growing and collapsing, growing and collapsing. And the refresh rate on this thing, it seems like it's grabbing it. It sees the signal, but it's seeing it when the signal is at its bottom end of the crest. So it's not seeing it as a static carrier. But it's not showing up any signal anywhere else. And so I was sitting there kind of playing with it. And then it clicked in my head, oh, I didn't show the input tune. Mr. R, you're good, man. You're off to the races and running. Gentlemen, my name is BBI, and without a shadow of a doubt, I'm the biggest mud duck in Idaho. I'm starting to fall out of love with Facebook, but come find me on Facebook, Snapchat, Instagram, Twitter, and if you are a first-time viewer of this channel, please take just a minute and click subscribe. Make sure to hit the little bell if you want to see the crazy shit that I do over here. It's fun, this is entertaining, and I'm always doing something a little bit different. That's what makes this so interesting, I think, for most people to watch. If you got any questions that aren't answered on my webpage, dial that number right there. Right there. And if I don't answer, I'll call you back. My voicemail is usually full by about 10 o'clock in the morning, on average every day. And I clean it out every night. So, all right, I'm out of here. I got other stuff I got to get on and go do. I'm done playing. Let's see, I showed output power and peak, showed it in average. Showed the input reflect, talked about what I was doing, what I did, how I was going to do it, how many jelly beans I was going to count. Yeah, I'm good. I'm done. All right, guys, I'm out of here. We'll see you. Bump, bump.